We're going to look at the topic of hypothesis testing, sometimes also known as significance testing. And while there is a difference between the two, we're not going to focus on that difference. The concept of hypothesis test is just general, meaning that while we're going to use the sample proportion to illustrate this concept, we could also have used the sample mean, for example, to illustrate this. Go and introduce the topic. Okay, and there's other statistics we could have used, but I'm trying to use ones that we've already become familiar with. The procedures that we will use, you have performed. It is identical to what you did in sample distributions for the sample proportion. All the conditions are the same. The scenario is the same. So if everything's the same, what are we doing? There's an entirely logical structure to the process we did earlier that we need to explore. The logic and its accompanying vocabulary are what appears in journals, along with the concept of confidence intervals, which we will look at next. So what is the purpose? To determine if, and a big if, the value of a known parameter is no longer the correct value. So we're going to try and determine if we have a known parameter, if there's any evidence that it's no longer correct. So the logic is this, a hypothesis test. The parameter is assumed to be true. And known. How do we know this? How do we know it's true? Through time, things eventually are treated like parameters. In most of the scenarios that we care anything about, like in medicine, once we establish some value and through time it seems to be effective to how are we going to use it, it eventually gets thought of as a parameter. So again, we start out with this thing called a parameter, which is a known and assumed to be true value. Data is gathered to see if there's evidence against this assumed parameter value by using a statistic that is an estimate of the parameter from the data set that we collect. Okay? And what we're going to do is use that value, this estimate, as a cutoff. For a set of more extreme possible statistics. So that our summary from the data is going to be used as a cutoff. And then we're going to look at, well, cutoff for what? For a set of more extreme possible statistics that never did occur, but it's the beginning of a range of numbers. If our statistical is unusual, then we wonder if the reason for this is the assumed value of our parameter is not correct. The hypothesis test can be used to rule out the possibility of a parameter value, the one that we assume to be true. But I cannot tell you what the parameter value actually is. Example, is chicken soup up with colds? Well, we don't know for sure, but there have been studies that suggest that it can help relieve the symptoms of colds, and there's reasons for this. Could it actually speed up with a cold? Potentially it can. And there's again been some studies for this, but actually just recent studies. Now, why do I bring this to attention? Because when you get a cold, maybe somebody in your family says, "Why do you eat, eat some chicken soup?" Well, do they know it works or not? Have they done a test? Are they using this? I mean, do they know it for a fact? And the answer is they just assume it to be true and known, a known fact. And that's how hypothesis starts. Tests start with an assumed value that is, again, assumed to be true and known. How that becomes to be elevated to that position depends on each situation. Here are vocabulary that we're going to look at eventually. So you take a look at this, and as you encounter vocabulary, just kind of check these off. Here's an article from the Journal of American Medical Association, dated February 6, 2024, and the effectiveness of bivalent mRNA in COVID-19 vaccines. We're not going to go through this. All I wanted to point out is that I mentioned that indeed this, what we're about to look at, is a very general idea. So I'm going to scroll down here, and you have the results here, conclusions about these vaccines. And it goes on, and it talks about here about the methods. And again, when you get to the statistical analysis, you start getting more detail what's about to happen in the next few pages. Descriptive statistics comparing participants who had SARS-CoV infection during the study period versus participants who remained uninfected included frequency proportion for categorical variables. Notice I measured the median, the IQR for continuous variables. And now you get to this other unknown ideas. The p-values were calculated using this thing called chi-squared test for categorical and Wilkinson tests for continuous variables at the 0.01 level. So what does this have to do with what we're about to discuss? Chi-squared is another form, it's another type of, like a z-score. It's a standardized value. The probabilities that we've calculated previously in sampling distributions will now be known as p-values. This value here at the 0.01 level has meaning as well. In fact, this is known as a significance level. As I mentioned, everything we're going to look at is specific to sampling distribution of proportions, but the reality is it's a very, very general idea. So notice right here, there's your p-value that was mentioned there, and that 0.01 that was also written down, that's your significance level. So all these words here that you see are found in studies.